Okay, so in this slide we will take a look how we could differentiate the inverse trigonometric function of sine inverse x. This is a sine inverse x is a function whose domain is from -1 to 1 and range lies between from -π/2 to π/2. This is the range of the function and the domain is from -1 to 1. We will make use of the graph to derive this result of sine inverse x. ddx of sine inverse x is 1 by square root of 1 over square root of 1 minus x squared. Now we will make use of this graph to derive this result. Okay, so as y equals to sine inverse x, therefore we can write from here this implies sine y equals to x, where the domain of the function is from -1 to 1. Now, if we differentiate this with respect to y, we will get cos y. We have x equals to sine y. Now we can use implicit differentiation. This is a case of implicit differentiation, but we are differentiating this with respect to y. So dx dy equals to cos y. If we differentiate this above equation 1 with by using implicit differentiation, then we would have got the factor dy over dx, another factor on the right hand side, but we are making use of this differentiation. Dx by dy equals to cos y. Now from chain rule we have dy by dx is equivalent to 1 over dx by dy, that we know from chain rule. Okay, so therefore we could write this as dy by dx equals to 1 over cos y. Now here we should make use of a trigonometrical identity, sine square y. We know that sine square y plus cos square y equals to unity 1. So from here we can write that cos square y equals to 1 minus sine square y. Okay, so let me come over here. Now therefore we can write, therefore cos y equals to plus minus square root of 1 minus sine square y. Now the question is, before the square root sign we have a positive and a negative sign. Which one we should take? See, if we look at the graph of sine inverse x, this is the graph of sine inverse x. Sine inverse x. where the domain of the function is from -1 to 1 and the range of the function is from -π/2 to π/2. Now if we look at the graph of this function, we can see that the slope, that is the gradient of this function sine inverse x, is positive throughout. So this is one reason why I should take a positive sign and not the negative sign. This is one of the reasons. Moreover, we can see that when our y value moves from -π/2 to π/2, from -π/2 to π/2, then cos of y moves from 0 to 1. That we can check with the help of graph also. For example, let me rub this part first. Okay. Okay. Let me draw the graph of cos y. This is our y-axis. This is our x-axis. Okay, so at this point we mark it as π/2, and this point is -π/2. This is a graph of cos y. Now, as our y moves from -π/2 to π/2, we can see from the graph of cos y this is our graph of cos x. So as our y moves from -π/2 to π/2, this part, our cos function, cosine function, is moving from 0 to 1. Therefore, so we can see that cos y is moving from 0 to 1. So this part is positive. Therefore, we should take the sign as positive. We have from this result cos of y equals to plus minus square root of 1 minus sine square y we remove this negative sign from here and we will take the positive value only. Okay. So this is where when the graph comes handy in determining the sign. So we have x equals to sine y. As we have y equals to sine inverse x, therefore we have x equals to sine y. So substituting the value over here, we are getting root over of 1 minus x square. So we have our dy dx as by positive square root of 1 minus x square. So this is the reason why we take use of the graph in determining the sign. And thanks for watching.